Today we are going to do an initial session on discussing why manipulatives matter, why it is such a key foundational part of math instruction and student learning. Additionally, these sessions will be to not only support our teachers, but also be a resource to support our paraprofessionals, our instructional assistants, and others who are working with our students during math times and when they're engaging with manipulatives. It's important for everyone to have a shared understanding as to why we do the things we do. And for these sessions, that is to understand why we use manipulatives, how it helps increase student learning. What are math manipulatives? Well, in general terms, they refer to tools that students can interact with, that they can physically see and physically touch and use to learn and solve mathematical problems. Some examples of manipulatives that we use, of course, at these younger ages are counters, base 10 blocks, number lines, cubes, place value charts. It can be using rulers. Any type of physical object that students can use to reinforce learning. While these tools may seem simple, they are very important. They play a large role in helping students make sense of mathematical ideas and concepts. And really, instead of just hearing about it or seeing it from like the instructional lecture standpoint, it allows students to, manipulatives allow students to actually experience the learning process through that physical touch and interaction with manipulatives, with those physical objects. Let's talk about how students learn math. It is very important to keep in mind to understand that students do not naturally begin learning math through abstract symbols and numbers. Those are items that represent real things. Instead, they learn best when they connect new ideas in concepts to something that's concrete, something that they can see, something that they can touch, something that they can manipulate. Thus, manipulatives. It's also very important, especially in the elementary grades, to understand that students need opportunities to build their understanding through hands-on experiences, touching those manipulatives, seeing those things, before they're expected to work with just numbers alone. Again, numbers alone are representations of real life things. So we got to, before we go into abstract, we have to have concrete. So when we skip that step, when we skip the physical components, the manipulatives components, students may be able to perform certain procedures or processes, but they may not have that conceptual understanding needed for further success when mathematical equations and problems become more and more abstract. Now let's take a look at an example. So let's say we ask students, like, what does 13 mean? They may be able to say 110 and 3 ones, but when they use base 10 blocks to physically build that number, they can actually see what that means. They have a physical representation of, oh, this is what 110 and 3 ones looks like. That visual and hands-on experience helps build and solidify their understanding in a much deeper way than simply just writing a number. This is extremely important, again, when math concepts are becoming more and more complex and more abstract. Okay, so what does it look like if students are not being taught using manipulatives? Well, when we're not using manipulatives or we're not using them consistently, students are going to have to rely on memorization and procedures to complete mathematical tasks and activities. They may learn steps to solve problems, but maybe not fully understand why those steps work. This can lead to confusion when they encounter, again, more complex abstract problems, such as regrouping, place value, or following multi-step directions and tasks. Over time, this gap between procedures and understanding becomes more and more noticeable. We'll start seeing more gaps in students' understanding and ability to complete those more complex problems. So, when we are using math manipulatives consistently and regularly, students are more likely to show better understanding, and they also have increased engagement. They're more likely to be able to explain their thinking, make connections between concepts, and approach problems with more confidence. More understanding equals more confidence. Manipulatives also support various types of learners by providing different ways, multiple ways for them to access the mathematical content. Overall, it's important that just to note that manipulatives help students move from simply just doing math equations and problems to truly understanding math and what it absolutely represents. The key takeaway from this session is really just, if we could just sum it up, students need to see and experience math before they can fully understand and apply it. Manipulatives are not just a support for struggling students. They are a very important and powerful instructional tool that should be given equal access to all students. As we close out this session, let's do a little bit of reflection. So consider your classrooms. Think about when are students using manipulatives? And are they being used during whole group instruction or primarily during small group or during interventions? Are we being consistent in their use across all instructional platforms, whether it's those times and those places and activities? Additionally, let's process whether or not all students have equal access to the manipulatives, to use them to have hands-on opportunities. Thinking about are we doing small groups and we're sharing one manipulative across the whole group versus everyone in a group having access to the manipulatives, using them at the same time in their discussions and in their mathematical practice. Thank you for giving me this time to do a little bit of professional development with our team here, and I will see you next session.